All right, we're going to keep looking at parametrics with derivatives here today. Last lesson we looked at how to find the first derivative. Here we're going to look at second derivative. Second derivative of a parametric, we want to take what's the derivative of the derivative. That ends up being what's our derivative in terms of t of our dy dx over dx dt. Notice it does not become just the second derivative of dy dt over dx dt. Don't do that. You have to take what's the derivative of our derivative of our first derivative in terms of t over dx dt. All right, so keep that in mind as we go through some of these problems here. So for first example, we're going to be looking at here, curve C is defined by these parametric equations. Find the points on C where the tangent is horizontal or vertical. Well, if we're talking about tangent lines, we're going to need to find the derivative. So let's start there. So we want to find what is dy dx. For parametric, what we talked about last time, that's going to be dy dt over dx dt. So finding our derivatives over there, dy dt, if we find derivative of this, it would be 3t squared minus 3 over, now let's find derivative of this in terms of t, that would just be 2t. Okay, so that's our derivative of our Cartesian equation if we had it in terms of y and x. Okay, so now to figure out where this is horizontal, okay, that would be where the slope is 0. And slope will be 0 when the numerator is 0. So for horizontal, set equal to, you want to set numerator equal to 0. If we want to find where where the tangent line's vertical, that's going to be denominator, because if you have 0 on the bottom, you can't divide by 0. That's undefined. That's when you have vertical slope. So for vertical tangents, that's denominator equal to 0. So let's solve out and see what we get. We'll start with the horizontal ones here. So if we have 3t squared minus 3 equal to 0, looks like we can factor a 3 out there. Now, the only part we need to put equal to 0 is the part with the, well, let's actually factor that. If we factor that, that's t minus 1 times t plus 1. That first one, we don't need to set equal to 0. You can't set 3 equal to 0. The other two, though, equal to 0. Looks like it produces, plus 1. You're going to get 1 and negative 1 here. So there's two points when the parameter t is 1 and negative 1 where this is horizontal. They did want us to find those points, though, the points here. So make sure we still find those. So the points where it's horizontal, then, where you got horizontal tangent, when we plug t in for, or t of 1 in for both of these equations, see what you get. So if you did in the first one, 1 squared is 1. If you put in the second one, you got 1 of the third is 1 minus 3 would be negative 2. So 1 point is going to be 1, negative 2. Now you got to do the same thing with negative 1 and plug that in. If you plug negative 1 in, negative 1 squared again is 1. If you put negative 1 in the other one, negative 1 to the third power is negative 1 minus 3 times negative 1. That's going to end up being negative 1 plus 3 or positive 2. So the other point here would be negative 1, positive 2. So those are the 2 points where it's horizontal. Now let's look at where would you have those vertical ones. So now we're setting denominator equal to 0. That is going to be at 0. And so the place where we have the vertical ones now, so vertical tangent, that's going to be at what we get when we plug in 0 for that. So if you plug in 0 for x, that is 0. 0 for the other one's also 0. So our point for vertical tangent would be 0, 0. All right, next part to the same problem. Determine where the curve is concave up and down. Well, we know from prior problems when we want to find where something is concave up or down, that's going to include finding the second derivative. So our second derivative here, second derivative is the derivative of our first derivative over dx dt. All right, so let's figure out what that is. Here it's going to be what's the derivative of our top from our last problem came out to be 3t squared minus 3 all over 2t. And on bottom, our dx dt from the last problem came out to be 2t. So now we gotta figure out what would that end up being. To do that derivative of the top, it looks like we're gonna have to do quotient rule. So doing quotient rule here, we got low d high, which would be 6t minus high d low. Derivative of the bottom is 2 all over 2t squared all over 2t. I'm going to multiply by reciprocal so to get rid of this situation where we got fraction over fraction. So doing that, 2t squared times another 2t, now it's 2t cubed on bottom. On top, let's multiply that out. So we got 12t squared. I'm gonna think of this more as I'm gonna move the 2 in front that we had there. It's being multiplied. So we got to distribute here a negative 2t, which would be negative 6t squared plus 6. Finishing simplifying here now. Looks like our second derivative comes out to be 6t squared plus 6 all over 2t cubed. So that's our second derivative. Now, in order to find where this is concave up, concave down, we want to know where is it positive or also maybe not existing here. So what you want to do is figure out where would this equal 0 or possibly not exist. So we want to set both of these equal to 0 and see what we get. If you set the top equal to 0 and solve that, we could subtract the 6 to the other side, divide by 6. Looks like this is not going to produce anything though because we can't take the square root of a negative, so no values come from that. Where does this maybe not exist though? It looks like we can get a value from that if we put this equal to 0. We could take the cube root and then divide by 2. So at 0, we could possibly change concavity here. So to find out where it's concave up, concave down, let's make a little line. And this is for our second derivative here. Let's pick some test points. So if we pick like 1, if we put 1 in, the top's positive, the bottom's positive, so it's going to be positive here. If we pick something like -1, the top is still positive. Bottom though would be negative, and so it's going to be negative over here. So it appears on our graph from our second derivative here in our graph that this graph is concave up when t is greater than 0. So when t is greater than 0 or from 0 to infinity here, and it's concave down when t is less than 0, so negative infinity to 0. So that's where it'd be concave up and concave down. All right, just checking. You can see from our graph now that that these came out to be true here. So remember our point where it was vertical, we came up with 0, 0. Do we have a vertical tangent there? Yes. Points where we had come up where there's horizontal tangents were 1, 2, and 1, -2, and you can see, yes, we have horizontal tangents there. So that came out right. The part we just did was where is it concave up and concave down. When t is greater than 0, we had concave up. And so this one, when t is greater than 0 happens right there. That's when t equals 0. So you can see, is it concave up here? Yep. When t was less than 0, we got concave down. So t less than 0, that was all this part. Yes, it's concave down there. So it did, what we had did come out to be, in fact, true there.